Narrow AI has seen extraordinary progress over the past few years. AI systems have improved dramatically at translation, at games like chess and Go, at important research biology questions like predicting how proteins fold, and at generating images. AI systems determine what you'll see in a Google search or in your Facebook newsfeed. They compose music and write articles that, at a glance, read as if a human wrote them. They play strategy games. They are being developed to improve drone targeting and detect missiles. But narrow AI is getting less narrow. Once, we made progress in AI by painstakingly teaching computer systems specific concepts. To do computer vision, allowing a computer to identify things in pictures and video, researchers wrote algorithms for detecting edges. To play chess, they programmed in heuristics about chess. To do natural language processing, speech recognition, transcription, translation, etc., they drew on the field of linguistics. But recently, we've gotten better at creating computer systems that have generalized learning capabilities. Instead of mathematically describing detailed features of a problem, we let the computer system learn that by itself. While once we treated computer vision as a completely different problem from natural language processing or platform game playing, now we can solve all three problems with the same approaches. And as computers get good enough at narrow AI tasks, they start to exhibit more general capabilities. For example, OpenAI's famous GPT series of text AIs is, in one sense, the narrowest of narrow AIs. It just predicts what the next word will be in a text, based on the previous words in its corpus of human language. And yet, it can now identify questions as reasonable or unreasonable and discuss the physical world, for example, answering questions about which objects are larger or which steps in a process must come first. In order to be very good at the narrow task of text prediction, an AI system will eventually develop abilities that are not narrow at all. Our AI progress so far has enabled enormous advances, and has also raised urgent ethical questions. When you train a computer system to predict which convicted felons will reoffend, you're using inputs from a criminal justice system biased against black people and low-income people, and so its outputs will likely be biased against black and low-income people too. Making websites more addictive can be great for your revenue but bad for your users. Releasing a program that writes convincing fake reviews or fake news might make those widespread, making it harder for the truth to get out. Is it even possible to make a computer as smart as a person? Yes, though current AI systems aren't nearly that smart. One popular adage about AI is everything that's easy is hard, and everything that's hard is easy. Doing complex calculations in the blink of an eye? Easy. Looking at a picture and telling you whether it's a dog? Hard, until very recently. Lots of things humans do are still outside AI's grasp. For instance, it's hard to design an AI system that explores an unfamiliar environment, that can navigate its way from, say, the entryway of a building it's never been in before up the stairs to a specific person's desk. We are just beginning to learn how to design an AI system that reads a book and retains an understanding of the concepts. The paradigm that has driven many of the biggest breakthroughs in AI recently is called deep learning. Deep learning systems can do some astonishing stuff, beat games we thought humans might never lose, invent compelling and realistic photographs, solve open problems in molecular biology. These breakthroughs have made some researchers conclude it's time to start thinking about the dangers of more powerful systems, but skeptics remain. The field's pessimists argue that programs still need an extraordinary pool of structured data to learn from, require carefully chosen parameters, or work only in environments designed to avoid the problems we don't yet know how to solve. They point to self-driving cars, which are still mediocre under the best conditions despite the billions that have been poured into making them work. It's rare, though, to find a top researcher in AI who thinks that general AI is impossible. Instead, the field's luminaries tend to say that it will happen someday, but probably a day that's a long way off. If you want to learn more about myths and realities about AI, please read the article. Here you will find a small comparison table. I am sure that will help you understand better. Thanks for your time.